Okay, let's talk about trust. Can we really trust what an AI sees? I mean, we're putting this technology everywhere, in our cars, in our homes, but what if it's just, well, making things up? Today, we're going to dive into a framework from Microsoft Research called Argos. It's designed to teach AI a skill that is absolutely crucial: honesty. It's all about making sure that when an AI looks at the world, it sees what's actually there. So, what's the core problem we're even talking about here? Well, imagine a robot trying to grab a tool that's obviously blocked, or maybe smart glasses that confidently describe an object in a room that just isn't there. These aren't just little glitches. They're called visual hallucinations. And they happen because a lot of AI models are trained to just sound right, not necessarily to be right. And this brings us to the central conflict, this idea of plausible versus grounded. On one side, you've got plausible AI. It gives you an answer that seems totally correct on the surface, but it might be completely fabricated. Then, on the other side, you have grounded AI. And this is the goal. This is an AI that's not only right, but, and this is the crucial part, it's right for the right reasons, because its answer is tied directly to evidence it can see. Now, this gap between just sounding plausible and actually being grounded in reality, it isn't just some academic detail. It's a huge safety risk. When an AI is basically just guessing, even if it's a really good guesser, the consequences out here in the real world can be serious. This is the problem that absolutely has to be solved. This is the exact question the researchers at Microsoft set out to tackle. See, it's not just about getting the right output in the end. It's about building a process that is reliable from start to finish. How do you make absolutely sure the AI's reasoning is sound, so you can actually trust it when the stakes are high? And their answer is this framework called Argos. The best way to think about Argos isn't as just another AI model, but more like a brilliant, kind of strict teacher. It's a verifier that looks over the shoulder of the student AI and says, hey, that's a nice answer, but now show me your work, prove it. So at its very core, Argos is designed to reward an AI not just for getting the answer right, but for being able to prove how it got it right. The AI literally has to point to the specific visual evidence, the exact objects, the exact moments in a video that justify its conclusion. It's all about creating that undeniable link between a claim and the proof. So how does this AI teacher actually work its magic? Well, it uses a really clever two-step approach to build that trust from the ground up. Let's break down how it works. First, a super quick refresher on something called reinforcement learning. It's basically like training a dog, right? You give it a treat for good behavior, and you don't for bad behavior. The AI learns through trial and error. What Argos does is it makes the conditions for getting that reward much, much tougher. So here's the two-step process. First up, Argos acts like a curator. It sifts through just massive piles of training data and only keeps the examples that are both correct and clearly linked to visual proof. This builds a really strong, clean foundation. Then, during the actual training, it acts as a guide, handing out those valuable rewards only when the AI answers correctly and grounds its reasoning in that solid evidence. And just look at the level of detail Argos checks for. This isn't just a simple right or wrong. It's asking, okay, is the final answer correct? Do the things you mentioned actually exist where you say they do? Did the events you're referencing happen when you claim they did? And most importantly, does your logic actually make sense based on what we can see? It's like an incredibly thorough cross-examination. All right, so the theory sounds really solid, right? But does it actually work in practice? Let's take a look at the results when they really put this method to the test. The results were pretty much immediate and honestly striking. Models that were trained using Argos showed a huge reduction in those visual hallucinations. To put it simply, they just stopped making stuff up. And this chart here just brilliantly illustrates the performance boost. When you look at really complex tasks like 3D spatial reasoning or robotics, the Argos trained model, that's that third bar, it consistently outperforms not just the base model, but even a stronger baseline competitor. So it's not just more honest, it's actually more capable. Okay, but this is where it gets really, really fascinating. AIs are incredibly good at finding shortcuts, at cheating to get a reward without doing the real work. So how does Argos actually stop the model from just learning how to game the system? Well, the researchers ran this amazing head-to-head test. Without Argos, the model that was only rewarded for getting the right answer, its performance actually got worse over time. Yeah, its accuracy steadily declined because it was learning these clever shortcuts that looked right but weren't based on anything real. And here's the kicker. Here's why that happened. The model without Argos started to just ignore the actual video evidence more and more.
But in stark contrast, the Argos trained model got better and better at directly linking its reasoning to what was actually happening in the video. It was learning the right lesson: pay attention to the evidence.
This quote from the research paper just sums it up perfectly. The standard AI learned to gain the system. It became a master of making things sound good. Argos, on the other hand, trained an AI that was accountable to reality itself.
So let's zoom out for a second. Why does all of this matter so much? I mean, this isn't just about getting better scores on a benchmark. This is about building AI that we can fundamentally trust to operate safely and reliably out here in our world. What we're seeing here is a massive shift in how we approach building AI. Instead of trying to patch up errors and mistakes after they happen, Argos is all about building AI that is anchored in reality from the very beginning of its training. It's proactive instead of reactive, and that makes the entire system just inherently more reliable. And the potential impact is just enormous. We're talking about self-driving cars that are far less likely to see phantom obstacles, digital assistants that don't misinterpret what's on your screen and click the wrong button. This is really the foundation for creating reliable AI agents that we can finally trust in our homes, our factories, and our offices. So, I'll just leave you with this one final thought. The work that's being done on Argos really forces us to ask a fundamental question about the future of AI. If an AI can't show its work, if it can't prove why it came to a certain conclusion, can we, and maybe more importantly, should we, ever truly trust it?